Hello everyone and welcome back to yet another video. Today we are going to be doing flag 15 from the Injured Android application, and this challenge is called assembly, I believe. So if we would go back to our application, we can find the flag 15 activity, which is called assembly here. So if we would click on this flag 15 button here, we would see the activity that we need to exploit here. So we can see, first of all, that there are three numbers, 58, 40, and 42. It doesn't really tell us anything. We can try to enter a simple test flag, click on submit. It just gives us try again pop-up here. We also have these hints, but let's, before looking at the application itself, look at the source code. So if we would go to the application and go to the starting point here, our starting point is going to be a main activity here. And if we would scroll down and try to find flag 15 activity, we would actually do so by looking around. We can see go to flag 15 activity, and it is starting activity, which is an intent, which is assembly activity class. So if we would click on this assembly activity, we are going to be brought to this assembly activity here, which is actually the activity of our application here. So let's try to figure out the source code. We can also find this assembly activity down under BNAC Injured Android and assembly activity here. So we can see that it starts pretty generically like any other activity. It's being initiated here, and these are our hints that we have received from the application. So convert the byte array into a string, then reverse the XOR string, and then disassemble shared object file to find the XOR key. So we have these three strings, right? And then let's actually try to figure out what this application does. So by looking at it, we have seen these three numbers. So I'm guessing this would be hex 58, hex 40, and hex 42. So we can look at it later on CyberChef to try to figure out what are those three numbers. But by looking at the activity, I would guess that these numbers are just XOR numbers that we would have to reverse to find the actual string. Let's try to now figure out what this application does. So we cannot really find a lot here. We can see that it is doing something with activities. It is calling this J function here. And let's try to figure out how it parses the input. So if we will scroll down here, we can see the generic, we can see the classical like database from that we have seen from the other challenges, and this is the Firebase database that we have seen from all of the other challenges. But we can start seeing some hints. For example, here it is loading library, which is called native lib, and because the challenge is called assembly activity, I would guess that we will have to reverse engineer this binary that we will find in the application later on in the video. And scrolling down, we can see that this is just loading the binary here, and this is getting a string from GNI. So I believe it is calling the class from the binary native lib, but I'm not exactly sure. Let's actually try to scroll down here a little bit more. It's starting some activity here. We have something here, something here. We cannot really make sense of it. We would have to reverse engineer the application a little bit more, but because I am trying to make this video not too long, I'm just gonna go through this a little bit quickly. And let's try to see here. It is doing some it is assigning a text view, a toolbar, something like that. And we do not really get anything here. We also get a string from JNI here. It is the same thing that is being assigned to Z. Let's try to find what is Z. We are getting a string, and this string is being assigned to this.z, and the Z string here, not exactly sure how this is working, so I cannot really tell you anything on right now because I would have to look at the source code a little bit more carefully. But I would have to guess that the application is taking something from the native library, and it is doing something, not taking, but maybe giving the string that we are giving to the application to the native library, and then native library is giving us some sort of a string here. And if this string is null, and it is maybe doing some kind of comparison here, and then it is checking whether the string is the same as the flag that we are submitting to the application. I hope this makes sense, and let's try to now reverse engineer this native lib library to make sense of what it really does. So I'm just gonna put these strings on my second monitor so I can just see them when I go to my Kali Linux here. And when I go to my Kali Linux, I'm just gonna open up CyberChef as the first thing, because we have seen these three strings and we would maybe like to figure out what those strings are. So CyberChef is a great website. I would have to turn off my burp suit, and I will search for the CyberChef again. It is a great website to help you decode some stuff, and as you can see, it has a lot of options. If you haven't checked out the CyberChef yet, I suggest you to do so. And now let's try to decode from hex. The limiter will be maybe space, and then we will have to enter these three numbers, so 58, 40, and 42. It is saying X and B. It is really nothing too interesting. We can also automatically, and it is just decoding from decimal, and it is giving me this, I don't know if it's a colon, then it is giving like a sad smiley face, right? I'm not really sure how to see that, but yeah, these strings are the smiley face, or from if we are decoding from hex. I'm not really sure whether we should decode from hex or from decimal. It is giving us X and B. So we do not really have anything too much of interest here, and we will have to find that native lib library that we have seen on the application. So when I go to my terminal, I am going to decompile the application and look for that library in our libraries folder. So to decompile the application, we will have to use APK tool that we have installed in one of our previous videos of a hacking Android application. So APK tool D, and then enter the file name here. It is going to take a few seconds to decode and decompile, and in a second we can see that it is finished and we have this injured Android folder. So I will just cd to this folder, and then we will go to the libraries folder because we are looking for some sort of a library. So cd lib, and then let's actually choose maybe x86_64 because we are on Linux application, Linux host here. And then let's try to ls, and we can see some SO files, which are just library files, as well as we can see this libnative-lib.so file. So this is going to probably be the file that we will want to reverse engineer, because we have seen that the application loads something called native lib, I believe. So let's try to reverse engineer this binary just now by using Ghidra or Ghidra. I'm not really sure how to pronounce this tool. It is a tool created by NSA, and it is a very good tool if you're doing reverse engineering. It is not the best, I believe. At least for me, the best is IDA Pro, because IDA Pro is a very advanced reverse engineering application, but it is paid, and I don't really have a license to it, so I'm just gonna use Ghidra for this project. So Ghidra libnative-lib.so, or we will open it in Ghidra later, or we will have to open it in Ghidra later. I just realized that it is not really how Ghidra works here. So also to import the application. As you can see, I have it already imported here, the application, because I was doing it before. But to import it, we will have to click on import file, and then we will have to find the our library, and then click on the libnative-lib.so here, and then select file to import. It is going to ask us for the format. I think the Ghidra is basically always right on these options, so we will leave them as default and click OK. I cannot click OK because I have already it imported to my Ghidra application, so I will just click on this green dragon and it will open our Ghidra decompiler, and we will see the source code of the application here. It is going to be in C and assembly because the Ghidra disassembler is going to disassemble the application into the assembly source code, and Ghidra is doing something to turn it to C code, so it is a bit easier for us to read. So let me actually just move it to the third pane, and I have CodeStripe open, so I'm just gonna close it now. And then we have this Ghidra window, so to open our project we will click File, Open, and then libnative-lib.so. Okay. And let's try to analyze this file, because we are opening this library for the first time. It is asking us whether we would like to analyze this application. So it would give everything to us here. I like to click Select All, then click on Apply and click on Analyze. So it analyzes all of the application and doesn't miss anything important or something like that. We can see down on the bottom right that it is decompiling the application, analyzing functions and stuff like that, and it is going to give us a clean assembly view of the application. Also, we will see here on the decompiler some C code that we can reference to. Also here we can see the assembly of the assembly source code of the application, not of the application, of the library that we are decompiling or disassembling. So I believe our Ghidra is done analyzing the file. It can take much longer, but you can start looking at the file right when it finishes analyzing it, or even when it is analyzing it, you can also look at the functions here, and when it finds new ones, they will just appear under these functions here. So we can see that there are these functions. So one is encrypt decrypt. We can see the source code here. This is a C source code, and as you can see, the variable names are really weird. That's because Ghidra doesn't see them when they are compiled. Where variable names disappear, they just become like, as you can see on the assembly view here, they are being just called through registers and stuff like that. So we have this encrypt decrypt function and this Java binact injured Android assembly activity string from JNI function as well. And I'm going to guess that it is going to be our class, our function that we will have to analyze, because on the application source code itself, let me just open it here, we have this string from JNI, and if we look at this, we have string from JNI here. So that is good, and we have successfully disassembled the application, and we can start analyzing the disassembled source code. So first of all, I see that the function takes a lot of parameters here, so we do not really know what they're doing just now, so we are going to skip them. Also, the application is assigning a lot of variables here. It is not really anything too important for us, I don't think. We would maybe have to guess that some of them are like strings, some of them are string maybe sizes or stuff like that. Looking a little bit down, we can see this local 20 being assigned, and we have this basic string being initiated over here. And it is taking all of these parameters that were assigned through our calling of the function up here. If we would look at the application, I'm not really exactly sure how it works, but it is taking this string from JNI. Can I actually control click it here? Yes, I can. And it is just being called here, string from JNI, and is being assigned to a string. So I'm not exactly sure how it works, because over here it says that it is giving it a lot of parameters, but on the application itself, we are not giving it any parameters. I'm guessing that maybe the parameters are being assigned when we enter some kind of an input to the application here. So for example, if I type in test, maybe when I click submit, I get all of the parameters assigned, but I'm not exactly sure how it works. So we can see all of these parameters, and we can see this reference to local 38 parameter being assigned to win, right? And so we can maybe rename this local 38 to win. So if I click on L on my keyboard, we can rename the parameter, and I will maybe rename it to win question mark, because I'm not exactly sure what it is, but it may be that it is being assigned to win string here, and we would maybe make sense of it later. But let's just go ahead and look through the application, through the source code a little bit more. So we have something checking if bvar7 is true, and this bvar7 is being assigned to byte. So this win string is being converted into bytes. It is being AND with 1, and if it is equal to 0, then this boolean bvar7 is being assigned to 1. And if it is 1, it keeps this if statement succeeds. And if this win variable shifted by 1 byte to the right is equal to 0 as well, we are going to this lab 001 something down here, and it is doing some stuff with this lab thing. And if it fails, it is going to this lab. Alright, so if this bvar7 is true, and if this is true, it is going to this lab. If this is false though, and else if this local 30 is equal to 0, we are not exactly sure what it is. Not really seeing anything here. We would have to examine a lot more of the source code to make sense of it. I'm not really sure where it is being assigned to. A local 30. Well, if the local 30 variable is 0, then it is going to this lab as well. And if all of these fail, we are going to this loop, do loop, while uvar2 is less than uvar3. And this do loop, as I can see, is XORing maybe user input, and from what I have to guess, puvar6 might be user input. I'm not exactly sure though. Let's see, local 37. Yeah, I'm not exactly sure, but this do while loop is just XORing some sort of value and modifying it. Also, we have this win here, and the bvar7 is being assigned to something. bvar7, and if bvar7 is true, then this win is being converted to byte and is being shifted to right by 1. And yeah, so we basically have a little bit of sense of how the application works, and we can try a couple of things. So First of all, the easiest thing would be to try this win input, try to enter this win input to the flag window, and if it works, then this means that the win input is just being assigned in the application as a string, and it is being done something, and the application is doing something with this win string down here, XORing it somehow, and then we are getting some sort of an output. So if it does work, then the win is our answer, our flag. If it doesn't work though, then we would have to make a script that would reverse all of this junk that we have here and would give us the variable that we are required. Alright, so first of all, let's go to the application and try to enter win here. If I enter win and I click submit, it actually does work, and it says congratulations, you have found the flag. So it was not really a lot of difficulty getting this flag. It was not really difficult, but as far as I can see, we can also take maybe this string over here, and then this string would, if we would perform all of these XORing functions with this string here, we would also get this win string here. So I'm not actually going to create a script for this because I just want to, I don't really want to touch a lot of reverse engineering side. I really just like Android stuff, so because it worked, I'm not really gonna do that. If it wouldn't have worked, I would do that. So I guess if you want to see how I script this, then leave a comment down below. I could make a video on it maybe, but for this video, this is going to be it, and I hope you enjoyed it, and I will see you in the next one. Take care and goodbye.